Hello everyone. In our previous video, you have learned about the remainder theorem and how it helps us to find the remainder. Now we'll move one step ahead to learn about the factor theorem. It's a direct application of the remainder theorem. So what is remainder theorem? If those who are new, who has not seen the previous video, kindly go through it, the remainder theorem video, and learn about the remainder theorem from there. I'll briefly tell you that remainder theorem is when a polynomial is divisible by another polynomial, then you can easily find the remainder as p of a without using the long division method. Okay, and how you find a? You will find a by equating it to be 0, and then you will find x is equal to a, and that value you put it, substitute in the polynomial. That is your remainder. But when remainder is equal to 0, when this remainder is equal to 0, then x minus a is a factor of px. That is this divisor is a factor of this dividend. Okay. So I hope it's clear. This is a remainder theorem, and when remainder is 0, that is a factor theorem. So they both are related. Let's see this example. Find the value of k if x minus 1 is a factor of px, x square plus x plus k. Okay, this is a polynomial and it is given that x minus 1 is a factor of px. So we will see first the factor theorem. What is factor theorem? That when a polynomial is divisible by x minus 1, then remainder is equal to p of a, right? And this can be taken according to definition. When px is divisible by x minus a, then remainder is p of a. So we can find this is what? This is still here, it's remainder. Okay, and if it is a factor, then it means remainder must be 0. So we will do it 0. Why? Because they are telling you that x minus a is a factor of px. X minus a is a factor of px only if remainder is 0. Okay, so we will take remainder first. According to remainder theorem, we'll find remainder as pa. So for that, our polynomial, now let's take our polynomial is this x square plus x plus k, and this is divisible by x minus 1, and they're telling you that x minus 1 is a factor of this. So remainder should be 0. But what is remainder? That is p of 1. From here you can find, make x minus 1 is equal to 0, x is equal to 1. So p, this value of x you are substituting in this polynomial, that is your remainder according to remainder theorem. And factor theorem, your remainder is 0. So let's find p of 1. So p of 1 is 1 square plus 1 plus k, and p of 1 is equal to 0. So let's solve this. 2 plus k is equal to 0. This implies k is equal to minus 2. So this is a value constant of this polynomial, and this polynomial x square plus x minus 2 is divisible by x minus 1, then remainder is 0. Okay, so next let's move on to the another example, which is also very important example. So let's see what should be added to 2x cube minus 3x square plus x, so that when the resulting polynomial is divided by x minus 2, the remainder is 3. So what they are saying, students, this polynomial is not divisible by this. Don't get confused. They are saying the resulting polynomial is divided by x minus 2. So what is the resulting polynomial? When something has to be added in this. So let's name this polynomial as small px. This is a polynomial and I have to add something in it. So you can say let c should be added. You can take any variable. Should be added to px small 1 to get resulting polynomial. So what is resulting polynomial? I will take it as px capital 1. This polynomial now, second line, let's come to the resulting polynomial is px. And this polynomial, when it is divided by, let's find what is px. Px is resulting polynomial is 2x cube minus 3x square plus x plus c. Okay. See the difference. This is not a resulting polynomial. See, you are adding in it, then you are getting a resulting polynomial. Let's come to the second line. What they are saying? They are saying that when px is divisible by this capital 1, resulting polynomial is divisible by x minus 2, then remainder is 3. So they are giving you remainder. This is given remainder. So naturally we have to find remainder by the remainder theorem also, because already we are getting 3. Okay. So and we have to find C. So we will apply remainder theorem. We'll apply the remainder theorem, and according to that, when a polynomial, this one is divisible by x minus 2, then p of 2 is the remainder. So remainder is equal to p of capital P, okay, p of 2. Here also it's given remainder, and here also we can find, using the remainder theorem, we can find this one. So remainder is equal to 2 of 2 cube minus 3 2 square plus 2 plus c. Let's solve. 8 times 2, 16 minus 12 plus 2 plus 6. And this remainder will be equal to 6 plus c. So students, we have two remainders. One is given and one we have found using the remainder theorem. So can we equate both? Yes, because this is also remainder and 6 plus c is also remainder. So let's equate both these remainders. So we can say that 6 plus c is equal to 3. We can find c as 3 minus 6, and this is equal to minus 3. So this is a variable value, or you can say an integer or any number, which required number which you are adding to this polynomial to make it a resulting polynomial. Because they are asking what should be added to this. You have added c, so c should be added. So you can see that minus 3 should be added in the polynomial small px to make it equal to the resulting polynomial. And that polynomial resulting one, what it will be the resulting polynomial? Resulting polynomial will now be capital Px, and this will be 2x cube minus 3x square plus x minus 3. This is our resulting polynomial. And this will be divisible by, you can check students, this is and when this is divisible by x minus 2, then you will get the remainder. You can check that. Remainder will be equal to 3. You can find it out. You can try using long division, or by using remainder theorem, you can find that remainder. You can check that remainder is coming out to be 3. Okay, let's move on to the one more question I have for you. This I am giving you as an assignment, but I will explain you what is it. Okay, and briefly the clues also I'll give you. Calculate the perimeter of a rectangle whose area is given. So now area is given, and you need to find area is this one. Minus 35x plus 12. This is area. And what you need to find? Perimeter. So what is perimeter of rectangle? Twice of L plus B. This you need to find. Okay? Question mark. But how will you find L and B? Because area is given here. Nothing else is given. Only area is given. You know that formula, that area is equal to length into breadth. Okay? And how will you get length and breadth from this? You have to factorize it. You know that this is a quadratic polynomial, and quadratic polynomial always have at most 2 roots. So you will get 2 factors. Okay, one is like this and another also. How will you find these factors? By using the splitting the middle term. You can find splitting the middle term, you will find the 2 factors. One will be L, another will be B, and L and B will be in variables, right? So the final answer, I can tell you that final answer will be 2x minus, I think 20x minus 14. This will be your final answer. Check that, are you getting the perimeter this? So if you are getting this as the answer, it means you have correctly solved it. Okay. So I hope I made myself clear to everyone. So keep in touch with me, and I'll make more subtopics for you so that you can understand each and every topic. Thank you, students, and do write in the comment section any topic you want. I can make it earlier. Thank you very much. Have a good day.